Okay, this is a video for the homework for the integration by parts homework. So this is Unit 6, Day 1. I'm just going to do a few examples from that homework. So integration by parts basically says that if you look at an integral and you think maybe you'd have to use product rule to take the derivative, but it is not a u substitution problem, then it would be a good candidate for integration by parts. So for example, in this problem, you might first try to do u substitution, but then you'd notice the derivative of this thing would be 2, and that doesn't leave you anything to do with that x value. So you're like, well, u sub's not going to be able to work here. So this would be a good candidate for integration by parts. And when you're doing integration by parts, remember your formula says that the integration of u dv is equal to uv minus the integration of v du. So you kind of have to assign values for those u and v's. Well, in here, I usually let the u be the x term. That usually makes it easiest. So do that. And that means that dv is the other part of it. So in this case, your dv would be e to the 2x dx. Okay? So once you have that, you want to be able to take the derivative of whatever you assign to be the u value. So now I'm saying the derivative of u with respect to x. So again, this u right here that I assigned, I'm saying that the derivative of that is 1. But notice in the formula that there's no du dx. It's just a du. So in other words, I need to get du by itself. So I multiply both sides by dx, and I get u equals 1 dx, or you could just write it as a dx. So you've got that part. And now you need to look at this dv and say, okay, well, if dv is e to the 2x, then you need to figure out what the v value is. So in other words, the integration of e to the 2x. So e to the 2x, the integration of that is going to be 1/2 e to the 2x. And if you needed to do a u sub there, you could, but really it's just, 1 over the coefficient of that exponent, and then you recopy it. So you've got that. Then you're just going to take those and plug them right into the formula. So I know that this thing now equals uv. So I take my u times v. So, and I'm going to put that 1/2 out front, and e to the 2x, so that's uv minus the integration of v du. So notice that my v has that 1/2, so I'm going to pull that 1/2 in front of the integral. So minus the integration of v, so that'll be e to the 2x, and du is, lucky for me, just a dx. So the whole point of this was that now I can rewrite it, and this part over here is now something that I know how to integrate. So when I clean this up, I'm going to go down here so I have more room. So I still have, and if you wanted, you could factor out that 1/2 from the whole thing, but I'll just rewrite it as it is so you can see it. So you've got 1/2 1/2 x e to the 2x, and then minus 1/2. The integration of e to the 2x is e to the 2x, and then you need a 1/2 out front. And of course, you're going to have a plus c tacked on at the end. So you can go ahead and clean this up. So when you kind of clean this up, you might rewrite it as 1/2 x e to the 2x minus 1/4 e to the 2x plus c as your final answer for number 1. Okay. Okay, so for number 2, again, this is integration by parts. You kind of look at it and you're thinking, I can't use u substitution, and this is attached by multiplication, so it makes it a good candidate for integration by parts. So for integration by parts, you need to assign a u value and your dv value. So normally I make sure that you can take the derivative of whatever you assign to u, and you can integrate whatever you assign to the dv value. In this case, they're about as equal, so usually I let u be the x term. So in this case, it'd be u is the x squared, and that makes sine x dx my dv term. So then I have to take the derivative of u. So the derivative of u with respect to x. So the derivative of that is 2x. And again, technically it's du over dx, but I'm going to multiply both sides by dx so that I get 2x dx. And then the v value, so now I'm integrating what I assigned as my dv. So the integration of sine, you need to go back around, so that's going to be negative cosine x. And we have that. So when you go to plug these back in, you're going to have into, again, that formula is, the formula is the integration of, that's not right. So it's going to be uv minus the integration of v du. So uv, I'm going to take that negative out front. So uv, that part's okay, minus the integration of v du. And I'm going to take that 2 in the negative and pop it out. So it's going to become plus 2 x cos x dx. Okay? So I get to here, and now I was hoping that by using this technique that this green part here would be something I knew how to integrate. Unfortunately for me, this is a case where I need to use integration by parts again. So now just on that green part, I'm going to eventually have to take that left-hand side and bring it all down, but just for this green part I need to assign another u. So I let u be the x thing, then the derivative of that with respect to x is going to be 1, multiply both sides by dx, so you just get dx. And then the other part is going to be dv, so that means that cos x dx would be the dv, and that means that the integration of cosine is going to be sine x. Okay, so now I got to scooch and get me some room. Okay, so I got myself a little more room. So now don't forget to recopy that entire first part that you already did. So you've got negative x squared cosine x. Okay, so I've got that blue part that I had from before, and I'm still going to have this plus 2, but now I'm going to use the integration by parts again, and so inside here I'm going to have u v, so those two things there, so it'll be x sine x plus, minus, that's a negative. So minus the integration of v du. So, yeah, that's fine. Oh no. Minus the integration of v du, so that'll be sine x dx. And now finally, that is some good news, because now I know how to integrate that part. So then your final answer for this problem, you're going to have negative x squared cosine x plus 2, and then I just kind of kept this because I'm just going to save stop it. Parentheses x sine x, and then the integration of sine is negative cos, so it's minus a negative becomes a plus cos x. Close that up, and because I integrated, there is going to be a plus c at the very end there. So that's that problem. All right, looking at number 3, you see an ln, and ln is definitely a big clue that you want to use integration by parts. And what you want to remember here is that you don't know how to integrate ln with any other technique than integration by parts. So since you don't know how to integrate it, it has to be the u value. So u is ln of x, and that means that dv has to be that x cubed dx. So then you're like, okay, well, the derivative of u with respect to x, the derivative of ln is 1 over x, and I multiply both sides by x to get the dx over there. And then I'm going to integrate dv to get to a v, so that means that v is going to add 1 to the exponent, so that 3 becomes a 4, divided by that number, so divided by 4. So you get to here, And now, again, you're going to be plugging into that formula that uv minus the integration of v du. So you're just dropping it into that formula. So you have your u and your v. So I'm just going to write the x to the 4th over 4 first. And my u was ln x. So I've got uv minus the integration of v du. So you've got this over 4, and then this dx. And I would do a couple of things here. The first thing I would do is realize that this 4 here can be brought out front as a 1/4, right? And then I would also realize that this x is going to take that and make it a 3 there. So that's going to make this a lot easier to integrate. So I think that it's definitely worth it to rewrite it. So this next line of work, this part stays the same, x to the 4th over 4 ln x minus 1/4. And now all I'm doing is integrating x cubed with respect to x. So this problem then becomes a bit easier. So you can kind of give me a little more room here. Now to integrate that, the rest of it's just going to be recopied. 4th ln x minus, you got a 4th there, and then we're going to add 1 to the exponent, divide by that number, and of course there's going to be a plus c at the end. Right there's your safe stop. You may notice that these two can be put together and you could rewrite it with a denominator of 16 there. Another thing AP might do is just take out, the 1/4 that's here and this 1/4. So just be aware of other ways that they may rewrite the problem. All right, and then I'm going to also do number 8. There's one very similar to that on your test. Let me just move this stuff out of the way. Okay. So we'll go ahead and tackle number 8. So number 8 basically says the integration of f of x sine x. So this is different because you kind of have, an unknown, this f of x in there. And it says that that equals negative f of x cos x plus the integration of 3x squared cos x dx. Okay, so there's your problem there. Now, it should have said something on here, assuming c equals 0, okay, assuming c equals 0, what is f of x? So what you want to realize here immediately is that this kind of has that uv minus the integration of v du set up to it. So you kind of have to decide, well, what's what? Well, one of the things that I notice automatically is that this is normally a minus, and it became a plus. So I'm thinking that when I'm integrating, cosine, when I'm integrating sine, I get negative cosine. So that leads me to believe that I have to integrate this to make that become a plus, because that's how I'd get a negative cos. So I'm going to say that u must have been the f of x, and dv must have been sine x dx. And again, I kind of discovered that because, I know in the formula, normally it's a negative, but when they rewrote this, it changed to a positive. So there must have been some sort of negative being factored out there. And I know that when I integrate sine, I get negative cos. So that definitely kind of led me down that road. So then once you kind of assigned your u and your dv, just like before, you'd say, well, the derivative of u with respect to x, well, the derivative of f of x is f prime of x dx. And that means that v must have been negative cos x, okay, because I integrated over there. So then you kind of have to play like this little matchmaker game and decide here, well, what was what? And you kind of play matchmaker. I'm going to go with blue this time. So looking at this kind of right-hand side here, you can determine, well, I'm trying to figure out what this is. I've already got that negative cos x taken care of, so I'm really looking at that piece. So what that tells me is the f prime of x had to be that 3x squared. And once you kind of figure that out, then you're like, well, if I want to go from f prime to f of x, I have to integrate. So f of x has to be the integration of 3 x squared dx. And then you can just integrate that and it becomes, add 1 to the exponent, divide by that number, and, you can get your answer that way. So we know that that is just, if you add 1 to the exponent, divide by that number, those 3's cancel. So I'm saying that that f of x was x cubed, and again, technically there is a plus c there, but the easiest way to do the problem is to assume that c equals 0. And there's definitely one like that in your test, so make sure you kind of review that. Okay, that's what I'm going to do for the integration by parts homework. If you have extra questions, the answer keys are available on Canvas. Have a great day.